the majority of people solve by substitution, which I think makes sense because you already know what y is equal to. So you can sub that in. You do have to be really careful when you do this one by substitution because you have to subtract y, but y is now 2 terms, x minus 3. So you have to protect it by parentheses. So I always, whenever I have minus a group of parentheses, I change it to adding the opposites of everything inside. That way I don't miss that minus negative 3 is really plus 3. So then you get 2x plus 3 equals 7. Subtract 3, 2x equals 4, x equals 2, and then you just have to plug it back in, y equals 2 minus 3, so that's negative 1, and your ordered pair is 2, negative 1. Okay. Now I also saw, I think it was Lexi's, Lexi's worked out really nice on A. She actually maybe noticed that, like, look, you have a minus y here, and then you have a plus y. You could solve by elimination. You just have to move this x to the other side. So I'm going to show she did 3x minus y equals 7. Then she moved the x over, so that's negative x plus y equals negative 3. And the y's cancel out. She gets 2x equals 4. And, of course, she's going to find out x is 2 and solve again. Okay. And then I saw Kirk also did it a little bit different. He solved for y in this equation. So if you solve for y in the first equation, he added y and subtracted 7. So this is really y equals 3x minus 7. And then if both of these things are equal to y, you can use substitution and set them equal to each other. So there's lots of ways to solve these two variable systems. I like all of those methods. That was amazing. I think most people on B, did elimination, so I want to show elimination. It's set up nicely for elimination because x and y are on the same side together. But in order to use elimination, you need, like what Lexi had over here, you need opposite coefficients. So if you want to eliminate x's, you could just multiply this first equation by a negative 2. So that you get negative 2x minus 8y equals 0, because I'm distributing it to all three terms right there. Stack it underneath with the 2x minus 2y equals negative 5. So the x's eliminate, you get negative 10y equals negative 5. Divide by negative 10, and be careful here, it's not 2, it's 1/2. You have a smaller number, negative 5, over a bigger number, negative 10, so that's a fraction 1/2. Is it okay if your answer isn't a nice number? Yes. Okay. And then you can plug that in, x plus 4 times 1/2 equals 0, so that's x plus 2 equals 0, therefore x is negative 2. So as an ordered pair, we would have negative 2 1/2. Okay. And you could also solve that one pretty easily by substitution. If you wanted to solve this one by substitution, I would solve the first equation for x. So subtract the 4y, and then everywhere I saw x, put in a negative 4y. Okay. Real quickly before we dismiss, this last one, how did you guys end up solving it?
No solution.
What method did you use? Substitution, elimination? Substitution. So what did you solve for?
I solved for y on the first.
Okay, so I just heard Chase say he solved for y in the first one. That's y equals 3 minus x.
Yeah.
Sorry. And then substitute that in. 2x equals negative 2 times 3 minus x plus 4. That's 2x equals negative 6 plus 2x plus 4. If you move the 2x, they cancel out. You get something like 0 equals, you have negative 6 plus 4, that's negative 2. How do you feel about the statement 0 equals negative 2?
I don't like it.
We don't like it. It doesn't make sense, right? It's really saying 0 is not equal to 2, which is false, and it means you have no solution. What kind of lines must you have if you have no solution?
Undefined.
2 lines that are
Oh, parallel.
Parallel, they're never crossing. They don't share any points in common. Okay. What happens if all your variables cancel out and it's true?
Then they're the same line.
Not all real. Something close to that.
Oh wait, no, they're perpendicular.
No, they are the same line. What do you say for your solution if you get like 0 equals 0? Not all real numbers. No, there is a lot of them, so many you can't count them. Infinitely many solutions. It's different than saying, I still have like 1 minute. It's different than saying all real numbers, because if you're saying all real numbers, you're saying anything works. But it's not all real numbers, it's an infinite amount of particular solutions. Okay, before you leave, let me just say one quick thing about your homework assignment. It's page 29, numbers 1 through 5. This is a little bit different than your previous homework assignments. It's the exploration before section 1.4. So it's not going to look like regular practice problems. It is page 29. Start at the top, read the directions, and answer 1 through 5. I put read pages 30 to 32. If you get stuck on 4 and 5 and you have no idea what you would do with 3 variables, then you can read ahead in section 1.4. That's what we're going to talk about tomorrow. Okay, did we have 12:32 on our phones? All right, you're dismissed. Have a great day. Thanks for getting Trent out of the castle.